Okay, I'd like to work through this factoring strategies to consider with you. This is geared to honors pre-cal, and some of this is definitely review. So the first one here, the difference of squares, if you remember, a squared minus b squared factors down to a plus b times a minus b. So what I notice is I notice a perfect square here and a perfect square there. So the square root of 64 is 8, the square root of y squared is y. Then the square root of 625 is 25, and then the square root of x to the fourth is x squared. So one of them is a plus 25x squared, and the other one is an 8y minus 25x squared. So since we've got squares in here, we might be able to factor farther, but with these y's, I was just trying to give you a kind of a complicated one. We'll just stop here at that point. Complicated perfect squares. The next one is the sum or difference of cubes, and so that one is a cubed plus or minus b cubed equals, here's how I remember it, ab, a squared, ab, b squared. And then it's the SOAP, so it's the same, opposite, always positive. So same, if it's positive here, it's positive there. If it's negative here, it's negative here. Opposite means that if it's positive, this one's going to be negative. If it's negative, it's going to be positive. So I'm not sure if you've seen these negative plus, so we've seen the plus or minus forever. But the minus plus just means that this minus accompanies the top. The things along the top work with each other, and this is always positive. So that's the same, opposite, always positive, and that is SOAP. Just a nice little reminder. So sometimes when I'm teaching this to Algebra 2, what I would say would be, okay, well, a cubed is equal to 8x cubed, which means that a is equal to 2x, which means that a squared is equal to 4x squared, and that b cubed is equal to 125, and therefore b is equal to 5, and b squared is equal to 25. And so now I can use these things right here. I'm going to run out of room, but then it's a, b, a squared, ab, so I multiply those, so that's 10x, and then b squared, 25. I did run out of room. And then it's the same, opposite, always positive. And so this is how we would factor that. Sometimes in pre-cal we ask you to factor all the way down to linear. This may not factor nicely, but I could always do the quadratic formula to keep going on that. Okay, and then looking at this one, if I have a cubed is 216, that means that a is 6, and that means that a squared is 36, and that b, that's a b, pretend, is this. That means, I'm pretty sure that's 7y squared, and so therefore b squared is equal to 49y to the fourth. If I'm wrong, I'm so sorry. I'm tired. Okay, so then this becomes a, b, a squared, ab gives me 42y squared, b squared, 49y to the fourth, and then it's the same, it's the opposite, and it's always positive. Okay. The next one, factor by grouping. This is the one I did mention in class. If you were to, but what we'll do is we'll factor those two, we'll factor out of those two and see what happens. I see a x squared that factors out, x plus 5. I see a negative 9. Always take whatever sign that is, factor it out. Negative 9 times x plus 5. I see an x plus 5 happening in both of those. So it's x plus 5 times x squared minus 9. X squared minus 9 is the difference of squares. So I can go a little bit farther, and I can say x plus 5 times x minus 3 times x plus 3. Be aware, this is what I mentioned in class. I've seen kids do this before. They'll take this, and they'll want to factor by grouping, and so they'll say, oh, I'm going to factor out of these two and then factor out of those two. Well, no, now you've changed the whole nature of your problem. You are taking this binomial here and multiplying it by a binomial there, which is not what you want to do. So don't use that notation. I will take off points because it's bad math. And we don't do bad math in my classroom. Remember, you have to get good math done. Okay, so the next one is a u substitution, and we're going to introduce a new variable. We're going to let u, not me, but we're going to let u equal x squared. And so if u is equal to x squared, then u squared would be equal to x to the fourth. So I can rewrite this problem in terms of u, not me, which is u squared minus 13u plus 36. And now this is something that's a lot more familiar to me, a lot easier to factor. And I can say u minus 9 times u minus 4. But I need it back in terms of x. So that becomes x squared minus 9 times x squared minus 4. I can factor each of those because those are the difference of squares. X minus 3 times x plus 3, and then x minus 2 times x plus 2. So there are 4 strategies that I would expect you to be competent with. All right.